Hello friends, my name is Vasanta Jutla and I am doing my MTech first year. So today's my video is something about very interesting topic, that is cars, automotive. And as we know, in the previous years there were mechanical components, there were mechanical devices which were used in cars, and there was no relation with electronics mostly. But nowadays electronics has replaced lots of things of mechanical devices. When we say about electronics, the first thing which we'll remember is about the sensors, like automatic headlights, automatic parking system is there, then switch on the car like with automatic keys. So one of the sensor which I will be speaking about is yaw rate sensor. I know it sounds very difficult, but it's actually not, and it actually plays a very important role in ECS. What is ECS? Fine, I'll speak about it in the later section. So when it comes to yaw rate sensor, a yaw rate sensor is a gyroscopic device that measures a vehicle's angular velocity around its vertical axis. The angle between the vehicle's heading and vehicle's actual movement direction is called slip angle, which is related to yaw rate. So what does this actually mean? When a vehicle is moving straight ahead and it is actually taking a right or a left turn, the angular velocity from the vertical axis, how much it is moving, that movement direction is called the slip angle, and that is related to yaw rate. So as we see this car, the yaw rate sensor is situated somewhere near the below the seat of the front passenger or in the front panel. So gyroscope is actually a device which is used for measuring or maintaining orientation and angular velocity. As we say orientation, that is how much it is moving from the straight direction towards right or left. So that much angular velocity it will be measuring. Actually it is a spinning wheel or a disc in which the axis of rotation is free to assume any orientation by itself, which means whatever axis of rotation it is doing, that much orientation will be measured. So what does a yaw rate sensor do? Basically a yaw rate sensor or rotational speed sensor measures a vehicle's angular velocity about its vertical axis in degrees, which means if the car is moving straight ahead in its vertical axis and it is taking a angular turn towards right or left. So in order to determine the orientation of the vehicle as it hard corners or threatens to roll over, that will be measured by the yaw rate sensor. There are two types of yaw rate sensors. One is piezoelectric. In the piezoelectric type, the sensor is a tuning fork shaped structure with 4 piezo elements. Tuning fork shaped structure means it actually has a shape of tuning fork, like 2 forks at the upside and 2 forks on below side. So during straight ahead driving, the upper ones produce no voltage as no Coriolis force acts. So what is Coriolis force? Coriolis force is actually an inertial force that acts on objects that are in motion, so which is relative to a rotating reference frame. If it is rotating in right side or left side, in that relation that inertial force will be acted on the object. In the reference frame with clockwise rotation, force will act to the left of the motion of the object, and similarly vice versa. So the output signal will depend on this direction, whether right or left. But when in cornering, the rotational movement causes the upper part of the tuning fork to leave the oscillatory plane, creating an alternating current voltage, which means when there is straight ahead driving, the upper tuning forks will be done in a counter phase, will be given a counter phase oscillation. So when the voltage is upright, the bottom piezo elements will start to oscillate, and the upper section of the tuning fork with its piezo elements will start to oscillate, and it will also give counter phase oscillation. So there won't be any Coriolis force. When it moves in cornering or rotational movement, it will cause the tuning forks to leave the oscillatory plane and it will generate some voltage. This voltage will be proportional to the yaw rate and the oscillatory speed. and so the output signal will depend on its right or left direction. So this is actually a diagram, a kind of block diagram actually. So this explains us about some of the things. We can say A and B section, it has been divided into. A section is sensing section of the oscillating element, and B is the stimulating section of the oscillating element. Then these are the numbers I have given for oscillating element, acceleration sensor, so that it will be easy to understand here. So these upper section of the oscillating elements will move when there is no turn or no rotation, when the vehicle is actually moving in its vertical direction. When it is cornering or taking rotation, the lower part of the tuning fork piezo elements will start to oscillate, and so they will leave the oscillating plane, and thus the voltage will be generated. Piezoelectricity is the basic principle of this sensor. So what is piezoelectricity? Piezoelectricity is the electric charge that accumulates in certain solid materials in response to applied mechanical stress. Whatever mechanical stress we apply, in accordance to that in some of the solid materials, there is an electric charge generated, and which accumulates there, which gets collected there. So this principle is known as piezoelectricity. So the word piezoelectricity means electricity resulting from pressure and latent heat. Another type of sensor, yaw rate sensor, which I spoke about earlier, was piezoelectric, and now another type is micromechanical. In the micromechanical type, the Coriolis acceleration is measured by a micromechanical capacitive acceleration sensor placed on an oscillating element. This acceleration is proportional to the product of yaw rate and the oscillatory velocity. So the yaw rate is measured, and also the oscillatory velocity, like in how much angle it is turning or it is cornering. That velocity is, that speed is measured, and along with yaw rate, which is maintained electronically at a constant value, the acceleration will be proportional. So this is a tuning fork which I was speaking about. Next, how does the yaw rate sensor function? The yaw rate sensor determines how far off axis a car is tilting in a turn. When I was speaking about cornering, what does it actually mean? Cornering means a car is straightly moving, and in some turns, when a road is taking a turn, the car actually moves that side. So this is known as cornering. So how far off axis a car is tilting in a turn, using gyroscopes to monitor the slip angle. The slip angle, as I spoke in the earlier section, which means that how much angle it is deviating or it is rotating from its vertical axis. So the angle between the vehicle's heading and the actual movement direction, which is right or left. So the yaw rate sensor actually determines this tilt. This information will be then fed into the vehicle's computer, which is normally microcontroller, that can be anything. So this is fed to the computer to evaluate the vehicle's speed, the wheel speed, the steering angle, and the accelerator position. And if the system senses too much yaw, the appropriate braking force is applied. What does this mean? If the vehicle is taking turn and it has turned too much, if the system senses too much yaw, suppose the car is about to lose its balance, it will be taking a lot of turn. So this might make the car to lose its balance, an accident or something may happen. So if it is sensing too much of yaw, a brake will be applied automatically, and that braking force will be decided by the computer. So by comparing the vehicle's yaw rate to target yaw rate, suppose we are deciding some threshold yaw rate value. If this yaw rate goes above this yaw rate, then the computer will be taking a decision, something like that. So the onboard computer will identify to what degree the vehicle may be under or oversteer, like how much it is oversteering. Suppose it is oversteering a lot, then the vehicle may lose its balance, and even if it is understeering, they may also get some problem. So whatever corrective action it has to take, it will be taking. So corrective actions, what it may include? It may include like reducing engine power as well as applying brake. If we reduce engine power, automatically the speed of the car will be reduced, right? So as well as applying the brake is one of the corrective action. so that if brake is applied, it won't take the turn, and one or more wheels will be realigned. So, where is this yaw rate sensor located? It is typically located under the driver or passenger seat, as I shown you in the first picture. It is mounted on the level floorboard in order to access the vehicle's center of gravity, because it has to measure the direction from how much vertical axis it is taking off, like how far off axis it is taking from the center axis of the vehicle. So it has to be maintained somewhere in the vehicle's center of gravity. So after installation, a reset or recalibration procedure is generally required. A yaw rate sensor is needed for electronic stability control. So I spoke to you about ESC in the starting. I told I'll be explaining it in the later. So electronic stability control, also referred as electronic stability program or dynamic stability control, it is a computerized technology. What does this mean now? This improves a vehicle's stability by detecting and reducing loss of traction. So this actually plays a very important role in safety of a car. Suppose it is losing its traction, suppose it's skidding, the car is skidding. This ESC helps the car to maintain its balance. Its stability will be detected. Its stability will be improved. Loss of traction will be reduced, so the car won't be skid. So when ESC will detect loss of steering control, suppose the yaw, too much of yaw is detected, this means that the steering control is lost. So this will be detected by the ESC. It will automatically apply the brake to help steer the vehicle where the driver intends to go. Even if the driver is not in that position to control the car, he won't understand even that what is going on. In that time span itself, the ESC will understand that the car is oversteering, that it is taking too much of yaw, and it will control the car. So brake will be applied, and braking is automatically applied to wheels individually. Like 4 wheels are there, so 4 wheels individually brakes will be applied, such as the outer front wheel to counter oversteer or the inner rear wheel to counter understeer. Okay, so as we can say, there are problems with everything in this world. So yaw rate sensor may also get some problems. Okay, so symptoms of a bad or failing yaw rate sensor, it may also fail, right? So we can check that yaw rate sensor has failed when engine light will come on. We have to check when engine light comes on. Vehicle stability or traction control lights illuminate. Suppose if when the car is started at the first, it checks all its sensors, it checks all its microcontroller, everything is tested. Self-loop test is run in very little time span. So at that time, if yaw rate sensor is not working, the engine light will come on, and the vehicle stability or traction control lights which are there on the front panel, that will illuminate, and also stability control light will flash intermittently. So this was about yaw rate sensor, and I hope that you all have understood my video about yaw rate sensor very nicely. Thank you.